In this video tutorial, we will use WebLink to create a simple website tracking experiment. The project will illustrate use of the experiment configuration settings, how to edit and add participant properties and user variables, use of the camera setup, image and web page components, and how to create a repetition sequence. The project will implement a simple experiment that involves showing participants 4 different web pages from an online retail website. Each web page shows a food product. 2 of the products will be own label products and 2 are branded products. Half the participants will be given a leaflet containing information about healthy eating before performing the task. Each page will be shown for 30 seconds, and during that time participants can scroll up and down and view the entire web page freely. After viewing all the web pages, participants will be asked to make a purchasing decision. The analysis will focus on the time spent looking at different regions of the web page, for example the product information and the nutritional information. We will cover the analysis in the next video tutorial. Let's get started. First, let's save the project and give it a name. By default, projects are saved in the WebLink subfolder of the User Accounts Documents folder. The default experiment folder is one of the many things that can be changed in the general experiment configuration settings. So let's run through some of these settings now. You can choose whether you want to record the monitor or an external video device. For this project we want to show the web pages on a monitor. We will cover using external video devices in a later video tutorial. If you have 2 monitors attached to the PC running WebLink, you can choose which monitor will be used for the stimulus display and screen recording. If you're not sure which monitor is which, you can click the Identify button. You can choose whether to use the monitor's current resolution or set a specific resolution. You can also set whether WebLink should automatically minimize if you just have a single monitor, and whether to use the existing host PC screen settings or provide custom settings. If you're not sure what screen settings the host PC has, then it's worth filling these out. If you have a webcam and microphone attached, you can also choose whether to record video and audio. This can be particularly useful if you want to record participant reactions or verbal responses, for example in Think Aloud protocols. There are settings that allow you to choose the shape and colour of the gaze cursors that are overlaid in the preview panel during recording, and settings for sending TTLs if you have other recording equipment that you want to send sync signals to. If you have another computer on the same network, this can be used for remote preview. This allows you to see exactly what your participant is seeing on their screen with the gaze cursors overlaid. This is a very useful feature for usability testing scenarios. You can also define and create various hotkeys. Hotkeys can be used to send messages, which can be very useful at the data analysis stage. They can also be used to send TTLs, commands to the host PC, or initiate a drift check. Finally, you can define participant properties and experimental variables. We will create a participant property to code whether participants read the health leaflet or not before doing the task. I'm not interested in gender, so I can just delete this variable and add another property. You can choose the type of participant property. We'll create a selection so that we can choose one of the 2 options. Options should be separated by a slash. We will also create a user variable to code the type of pizza. Again, we'll create an option, enter the values, and assign the variable to the web page component. We'll come back to this variable shortly. Let's start building the actual experiment. Before we show the web pages, it would be nice to give our participants some instructions. To do that, we can use the image component to display a slide that contains the instruction text. I prepared the instructions in PowerPoint and saved the slides as an image file. The first thing we need to do is to add this file to our project library. Click on the library icon and click the plus button of the Images tab. Navigate to where the image file is stored and select the file or files to import. I am adding the instruction screen as well as the thank you screen to show at the end of the task. You can click on any imported files and see a preview and other useful file information. Next, we simply drag an image component onto the timeline. The Properties panel for the image component has an entry for source file, the file name of the image we want to display. Other properties allow the size and position of the image to be adjusted. You can also adjust the background color and whether the mouse cursor is visible. In the eye tracking section, you can change the message that is written to the EDF file when the screen is shown, choose whether to record eye movement data, associate the image with an interest area template, choose whether to send a TTL and whether to log key presses, mouse clicks and mouse location. As this is just an instruction screen, I'll set the preferences accordingly. In the participant response section, we can select whether the image presentation is ended after a fixed amount of time and/or a participant response. The instructions tell participants to press the spacebar, so I'll select that. Unchecking all button response options will ensure that only pressing the spacebar will terminate the image presentation and move on to the next component. Next, we'll need to set up the participant and eye tracker and perform a calibration. All of that can be done with the camera setup node. There are several properties that can be adjusted, including the number of calibration targets, the calibration target color and size, and target locations. For this project, we'll stick with the default settings. After the camera setup, we want to start showing the web pages. We only have 4 web pages to show, so one very simple way to implement this task would be to add 4 web page components in the timeline, one after the other. I'll illustrate that approach first, and at the end of the tutorial I'll show an alternative approach that is useful if you have a large number of different web pages or other stimuli that you want to present in a sequence. So I'll drag a single web page component to the timeline. There are several properties that relate to this component. We can give the component a meaningful label and choose which URL to show. I'll paste in the first URL from my list. We can also choose which browser to use, whether the browser runs in full screen mode, whether the close button is disabled, the size of the browser window, and the background color if the browser window is not full size. You can also choose whether to record the screen and computer audio and the screen recording frame rate. The eye tracking preferences allow you to set the message that is written when the component starts, whether to record eye movements during the recording, to send a TTL, and to log key presses, mouse clicks and mouse position. For this project, the default settings are all fine. Finally, as with the image resource, we can determine whether the page is shown for a set time duration or until a key press or mouse click. In this task, we want each web page to be shown for 30 seconds. The last property is the user variable we defined earlier. We can choose the appropriate value for this product web page. We want to show 4 web pages, so we can simply copy this web page component and paste it 3 times. Then all we need to do is adjust the starting URL and condition variable appropriately for each web page component. I'll do that now. At this point, we can check dummy mode in the experiment configuration settings and dummy run the project to check it is working as expected. I ran the project all the way through and it worked fine. So we can save the project, uncheck dummy mode, and start collecting data. When using WebLink for web page tracking, a dual monitor setup can be a real advantage, as it allows you to keep WebLink visible in one monitor while the participant views the web page on the other. Here you can see both monitors simultaneously. First, the instruction screen is shown, and when the participant presses the spacebar, the project moves on to the camera setup component on the timeline. As you can see, the camera setup process can be monitored in the preview window. After a quick check that the camera is pointed and focused correctly, the participant can be calibrated, and once that is done, the project moves on to showing the first web page. The browser launches and the first web page loads. The preview panel in WebLink shows the web page as the participant interacts with it, as well as a live gaze cursor. Everything is working fine, so I'll go ahead and run a few participants, and we can take a look at the data in the next video tutorial. I mentioned earlier that there is an alternative way to implement this design, which is to use a repetition sequence. This approach can be useful if you have a large number of different web pages or other stimuli such as images, videos or PDFs. To create a repetition sequence, we just need a single web page component, so we can delete these three. Select the component and right-click and select Create Repetition Sequence. In the window that appears, we can now add rows, one for each repetition. Next, we can choose properties, such as the starting URL that will change with each repetition. We can add other variables, for example the user variable we created earlier for pizza type, and code that appropriately. I'll quickly paste in the URLs. Finally, I'll adjust the labels. Repetition sequences can be created for multiple consecutive components. For example, in this case, each web page will be preceded by a different instruction screen and a drift check. I hope you found this useful. In the next video tutorial, we'll use Data Viewer to analyze some data collected with this project.